What is Hive? In this video, you will get a quick overview of Apache Hive, one of the most popular data warehouse components on the big data landscape. It's mainly used to complement the Hadoop file system with its interface. Hive was originally developed by Facebook and is now maintained as Apache Hive by Apache Software Foundation. It is used and developed by biggies such as Netflix and Amazon as well. Let's start understanding Hive. To do this, we'll need to get a grip on the following things. Why was Hive developed? How and when it can be used? When Hive cannot be used? Some of the finest features of Hive. Hive versus traditional RDBMS. Why was Hive developed? The Hadoop ecosystem is not just scalable, but also cost-effective when it comes to processing large volumes of data. It is also a fairly new framework that packs a lot of punch. However, organizations with traditional data warehouses are based on SQL, with users and developers that rely on SQL queries for extracting data. It makes getting used to the Hadoop ecosystem an uphill task, and that is exactly why Hive was developed. Hive provides SQL intellect so that users can write SQL-like queries called HQL, or Hive Query Language, to extract the data from Hadoop. These SQL-like queries will be converted into MapReduce jobs by the Hive component, and that is how it talks to Hadoop ecosystem and HDFS file system. How and when Hive can be used. Hive can be used for OLAP, online analytic, processing. It is scalable, fast, and flexible. It is a great platform for the SQL users to write SQL-like queries to interact with the large data sets that reside on HDFS file system. When Hive cannot be used. Here is what Hive cannot be used for. It is not a relational database. It cannot be used for OLTP, online transaction processing. It cannot be used for real-time updates or queries. It cannot be used for scenarios where low-latency data retrieval is expected, because there is a latency in converting the Hive scripts into MapReduce scripts by Hive. Some of the finest features of Hive. It supports different file formats like sequence file, text file, Avro file format, ORC file, and RC file. Metadata gets stored in RDBMS-like Derby database. Hive provides a lot of compression techniques, queries on the compressed data such as snappy compression and gzip compression. Users can write SQL-like queries that Hive converts into MapReduce or TES or Sparks jobs to query against Hadoop datasets. Users can plug in MapReduce scripts into the Hive queries using UDF user-defined functions. Specialized joins are available that help to improve the query performance. If you don't understand any of the above terms, that's fine. We will look into the above features in detail in our upcoming videos. Hive versus traditional RDBMS. Hive enforces schema on read. Schema on read allows the component to insert data without checking for the type or schema definition of the table. It verifies the data only when data is read from the table. Traditional RDBMS enforce schema on write. Schema on write includes verifying if the data is inserted as per the table definition and schema definition during the write phase itself. This is how RDBMS databases like MySQL or Oracle servers work. Hive allows you to store hundreds of petabytes of data because Hive stores data in HDFS, which has a scalable storage space. RDBMS have a max storage capacity around 10 terabytes of data, and querying such large data is not an easy task. Hive doesn't support OLTP. RDBMS supports OLTP.